Good morning, good afternoon, and good evening. This webcast completes the description or the overview of the Persistable Classes platform. It's a 5-course meal. A big focus is on the Level 4 structured storage model, named storage domains, reusable entities, indexed entity collections, and non-fungible entities. This presentation is brought to you by the C# Developer Center of Excellence. And you can find that on GitHub, or if you Google for Neo-C# COE. So a couple quick shout outs to Neo and Microsoft China for sponsoring the first Neo dev competition and the $500,000 US worth of prizes. First prize went to Sergio, and I'm highlighting his Nacho Man contribution for the uniqueness of it, but also he's been a huge contributor to the NPC project through his work on the Neo debugger. I'd also like to highlight Joe Stewart's Hush Puppies project and his non-fungible token project. He won third prize. And lastly, a thank you to Neo and Microsoft. Neo Draw, which is a multi-person shared whiteboard distributed application built with the Neo Persistable Class platform, won fourth place amongst the other projects that you see here on the screen. So some much appreciated recognition for NPC. So the purpose goals for this webcast are to describe and demonstrate that 5-course meal, the Level 4 structured storage model, named storage domains, the concept of reusable entities. And we're going to focus in on one particular one. You can kind of think of it as one that'll come with the platform, NeoCounter, which has a myriad of uses, and it's we'll talk about when we get to it. Indexed collections of entities, and how you easily work with indexed collections, and they can be indexed by strings, they can be indexed by integers. If they're indexed by integers, then the NeoCounter class becomes quite useful. And then lastly, we'll look at non-fungible entities and how, in fact, every NPC entity is, in fact, a non-fungible entity. So the level of detail I'm covering here is just at an awareness level. I'm not trying to go deep enough to call it education or training. It'll probably take half an hour to run through this. The principles I'm following is providing timely, accurate, visual, and complete information. Telling the whole story. So that you could imagine doing it yourself, even though it doesn't maybe go the full distance from a training perspective. Use as little time of yours as possible, or the crawler is not waste any more time than necessary. And but it sometimes takes some time to get through the material. The overarching driver is the need in the Neo.NET developer community to have concise and easy to follow documented approaches to enable enterprise developers to come up to speed building Neo smart contracts, but really the bigger picture, which is multi-tier distributed enterprise applications. Okay, so just to revisit a little bit that I talked about in the previous webcast, today we have this NEP5 token model, similar to ERC20 on the Ethereum. And the way that's generally used is like I show here, transfer from one address to another, to another, to another. And so in and of itself, it has some value, that capability, but it really doesn't represent a lot of business value. What people really want to enact are business processes. So here's a simple business process where somebody creates and submits a requisition. In this case, they're going to submit it to what I call an NEP-5R smart contract. That smart contract is going to enact a business process. So there's the submission, creation and submission of the requisition. And then either that requisition is going to be approved, rejected, or perhaps rerouted to somebody else for intermediate or final approval. And then finally, the third step of the business process is to pay the requisition, assuming it's approved. And so how do we bring these two worlds together? Well, if we go back to then we call this concept smart agents. It's the smart contract, the NEP5R smart contract, and the entities and the data that goes with it. We refer to that as a smart agent. So if we go over here to the left, rather than just have transfer, imagine at the top the operations that the smart contract understands are operations like create and submit, or approve, reject, or reroute, and finally pay. And what's interesting about these operations is that once you begin to think of them as part of a business process, you start to use different terminology. You start to use the terminology of the business process for your smart contract or your smart agent operations. So let's look at that in a little more detail. So here we have a traditional business process diagram, swim lanes diagram, and we've got the act of creating the requisition and submitting it. We submit it to the smart contract. That smart contract has a number of entities within it, both non-fungible entities and fungible entities. But more importantly, it enacts a business process and a set of business rules. So, for example, if the payment is less than some amount, I just picked $100 here, maybe the business rule is that requisition, that could be a timesheet or an expense report, just automatically gets paid. Maybe if it's over 100 but less than 500, maybe it has to be routed to an accounts payable clerk. Or maybe if it's over 500, then it maybe has to be routed to your manager or project leader or somebody who then approves or rejects it. It gets routed to the accounts payable clerk, and then you finally get paid at the end. So that's the requisition smart agent, and it's the code that represents the NEP5R smart contract plus the data, plus the entities, the non-fungible entities that it operates on. On the right-hand side are some more specific use cases. So I generically refer to these as requisitions, but it could be expense reports, timesheets, contribution reports, lottery tickets, loyalty points, discount coupons, vouchers, stock certificates, disbursements, remittances. And these could be second or third party, two-party or third-party activities as well. It's just a question of how complex do you code the business rules in your NEP5R smart contract. So this idea of a smart agent is a smart contract plus the non-fungible entities it operates on. In this particular use case we're looking at, processing requisitions, over here on the right is a bunch of the entities that need to be operated on by the code in the smart contract. The smart contract needs to have certain operations that operate on it. We've already talked about those: create, submit, approve, reject, reroute, pay, register. Plus, it needs to support the NEP5 operations to actually implement the pay, so things like transfer. And then something additional we're looking at is a new sort of standard operation called supported standards, so that you can reach into any smart contract and ask, which standards do you support? And so the idea is that supported standards would return the string NEP-5 to indicate that it supports all the operations defined in the NEP 5 specification, and then there'd be a separate specification for defining the requisitioned ones, the required operations that are in addition to what's in NEP-5. Let's say it's called NEP-1234. So supported standards returns a string, and it would have within it NEP-5, comma, NEP-1234. And we'll see how much traction that gets. So this whole thing, again, we call a smart agent. It's the smart contract, the code, operating on non-fungible entities. So just to clarify what a non-fungible entity is, it's any persistable entity that has one or more read-only fields that cannot be changed. The fields cannot be changed once the entity has been created. And again, if we think of those use cases, all of these represent non-fungible entities. There's some sort of ID, and perhaps the value represented or being requested would be non-fungible or immutable, non-mutable read-only properties. And this is a generalization of the work that Joe Stewart did with non-fungible tokens. And non-fungible entities can be used to create non-fungible tokens. And we'll see how easy that is to do with NPC. Let's look at the structured storage model. So it's actually reasonably complex. In previous webcasts, I've just focused on showing how to get and put entities using the traditional keyed storage model that Neo uses. But there's actually quite a bit more there. So you can click on this video now to stop it if you want to go through the legend. I'm not going to go through the whole thing, but I'm going to walk through the 4 levels of functionality that's in layered functionality that's in the Neo Persistable classes platform, and in turn explain each of these. So the first thing is we have level 0 and level 1. So level 0 just has the basic class that defines the entity. And also that's where the immutable field support will kick in. And we'll show you that at the end. But the important thing is because it's implemented at level 0, it means that it's implemented across all the other levels as well. Level 1 managed, we're showing here all the capabilities that are available for a managed entity. Managed entities aren't persistable. That's level 2. We'll look at that in a minute. So let's look at what a managed entity has. We have a constructor called new. We have new with all the different parameters for the properties. Null, we can get a null entity. We can ask if an entity is null. We have the ability to set all of the properties in an entity. We have the ability to set individual fields to a value and get individual fields. And then each entity has a specific log function which will log the entity in a standard way to the event log. And then to support the idea of reusable entities, we also have the concept of custom methods. Because usually when you implement an entity, you don't want just the standard NPC functions. There's probably some business level methods that you need to implement on top of that. And so to reach that higher bar of completely reusable standalone entities, we have the concept of custom fields. If we next look at level 2, persistable, this is where we add get and put. And in conjunction with get and put, we have the ability to create a missing entity. This is used internally in get. And then you can ask anywhere in your smart contract, is this entity missing? Meaning, is it missing from storage? So you might execute a get against a particular string key or a particular byte key, and if it's not in Neo storage, you can ask that, and NPC knows if it exists or not. And then, of course, there's custom methods that are supported there. One level up from level 2 is level 3, which is deletable. And this is the ability to bury or tombstone an entity that's in smart contract storage. This is separate from Neo's native support for the delete method. So that's the left-hand side here. This is what I've demonstrated previously in terms of the NPC layered support for the traditional keyed entity storage model. And it's built directly on top of the Neo hash table storage model, the key value pair storage model. And it leverages those managed capabilities that we saw in level 1. So now we're going to move over onto the right-hand side, and this is the named storage domain model. And so there's a hierarchy of domains, a hierarchy of containers, if you will, for organizing your entities. So you can have a parent domain, and within that you can have an indexed collection. And you can also have named domains within the parent domain, and we're going to see examples of all of that. To enable those, we start first with just level 4 collectible entities, and those are enabled using NPC storage keys and something called NPC Kong keyed object notation for geeks. I'm not going to go into those in too much detail other than how do you use them as a developer. The next level up is still technically within level 4, and this is where we support the put element methods. And put element really means put an element of the collection or an element of the array. So you can provide integer indices, you can provide byte array indices, which in effect also supports strings. You can get based on indices if you put them based on indices, and there's also you can also bury, and then the collectible methods. And we'll see NeoCounter as an example of a class that uses all of these capabilities, and it's also packaged as a reusable entity. Okay, so there's a growing theme within the development of smart contracts around composability. We've already talked about composability at the NEP specification level. The ability to have the external interface for a smart contract being composed of multiple standards, such as the NEP-5 standard plus, let's call it the NEP-1234 standard. But in terms of the internal implementation, we're going to see that once you start using reusable entities, it becomes very easy to compose the actual implementation of a smart contract. So here we're going to look at the concept of creating a user ledger, and I'm going to more formally define what a ledger is in the context of NPC after the demonstration. But it's made up of a user entity and a user counter, and the user counter is based on the NeoCounter NPC entity. So let's jump in and do the demo. So I've already created all the classes that we need for this. So the first thing is let's see what a ledger looks like. So we can see that a ledger is just simple. It's got a user script hash and a passphrase script hash, and they're both byte arrays. So you can argue whether whether we should be storing passphrase and stuff, but this is the example that we're going to use, and so that's one class, one model class, and it's of course in the so my project was called User Directory 1. It's in the model, And the way NPC works is you create model classes, then you run the NPC compiler against those model classes, and it generates all of those methods that we talked about when in the discussion around structured storage. In addition, we need the counter. Well, the counter is pretty easy. It just has a current number. But we want to have methods, more business level methods like take next number, and sometimes we want to be able to give back a number as well. So in a previous project, NeoCounter was developed, and then the code for that was captured. And if we go here into this CSI file, we can see that we have take next number and a full implementation of that, and get next number and a full implementation of that. So simply by just, and this is just kind of a placeholder, so that we're able to fully compile, this model class. So these three files together constitute a reusable class. You can take these and drop them into any NPC solution, into any model project. And the NPC classes will NPC helpers will automatically be created here based on the levels that you specify, and this implementation will be propagated into your smart contract as well. So the smart contract is actually implemented up here in the .contract project. The expectation is whatever your model contract model classes project is called, the smart contract project has the same name with .contract at the end. So to make this all work, we just simply go rebuild, and this will rebuild and create a DLL, a regular C# DLL, and we see that down here. And then I've hooked up to the debug settings, the debug configuration for this project. I've hooked up the NPC compiler. So if I just say debug, I'm not actually going to debug, I'm just using this to trigger the running of the compiler. And then the compiler runs quickly. It has generated all of the code. It's found our implementation in our model project and copied it over. We can see that it's generated all the levels for NeoCounter and all the layers for the user ledger entry. So if we close up the model project now and look at what we've created up here in the contract project, we can see that the NeoCounter is here. That's level 0 support. So we adjust the naming convention here. We make the method private so that you can only act on it through the methods, the getters and setters that are supported by NPC. We're not going to go through all of these in a lot of detail, but here's the managed code for level 1 managed, and so the ability to set the current number, the ability, because there's only one property, that one isn't so interesting, the ability to set all the properties again, which isn't all that interesting, initialize new, etc. And you can of course explore those with the debugger, or explore those in Visual Studio. A slightly more interesting example would be at the persistable level here, and we can see at the persistable level we have the implementation for isMissing, the ability to create a missing entity, and then here we see the gets and puts, the support for byte keys, byte array keys, and string keys, etc. If we go up here to collectible, this is where we find put element, where you provide something called a neo-versioned app user entity, the name of the domain, and the index that this entity you want this index to be this entity to be conceptually saved at, and it'll go through and create a neo storage key based on that with the domain and the class name. We then go ahead and extend that storage key using the index and the field name. So there's an encoding, a special encoding that takes place using those two routines to create the index value that storage put and storage get use. The ledger, the same sort of thing. I just want to highlight this because this is the class that we're going to demonstrate the non-fungible capabilities of NPC. So these are just two regular properties. And if we go down here to let's say persistable, we can see that they're just being put against the key in effect. There's even some massaging of the key done when you're supplying just byte array keys and string keys, where the name of the class is prefixed to whatever you provide as the key. This actually ends up being pretty important. I've looked at a number of the projects, recent projects that were highlighted both in the competition and the Neo Amsterdam event, and a number of them are just simply concatenating byte arrays together to make their keys. I think that's very dangerous because you're going to end up with collisions if you don't actually create an actual pattern for the way that you create your keys, because joining two arbitrary byte strings eventually will create a collision. There's 100% in the chance in the fullness of time you're going to create a collision, and when you're working with crypto assets, it's not a good thing. So people that are doing that in these existing projects should maybe take a second look at that. So that's just the quick Cook's tour. I've created a little contract here that's really just a test case driver. So if we go down here to main, we create this thing called a versioned app user. It takes the application name, the major, minor, and build, and this is like the out and the script hash of the owner. This is like the outermost container that NPC structure storage uses. So the app name is just a name. There's a version, major, minor, and build, and the owner hash. Again, this is designed to provide sort of maximum flexibility, and that tends to be constant for an application. It can change, but it tends to be constant for an application, and it's just passed in when you're using level 4 storage. But the counter itself is just an ordinary NCP class. So here I can create a new counter and initialize it with the integer value 1, 2, 3, 4. Put it out. I can put it into storage with the key my counter 1, and the actual key will be something like NeoCounter # my counter 1. And then we can get it back and dump it back out. So we'll just see that as an example. Here we're using level 4 storage, so we're using put element and get element. So I've created a domain here called mycounter2. So this is going to be a self-contained domain within this versioned app user container, and I'm going to put it at index position 0. So this is a way of just using domains. And I'm going to do the same sort of thing. I'm going to put element, I'm going to do a get element, and dump those out. Going down, it gets a little more interesting. So here I'm using those custom methods, take next number, and I'm calling it 3 times here. And what take next number does is it manages a persisted counter and automatically increments it. It sounds like it's fairly simple, and in theory it is, but if we go and look at the implementation, we can see that it takes the VAU, and we also have, in this case, an enumeration of counters. So this is a class, a single implementation of a class that can support basically an infinite number of different kinds of counters, or different instances of a counter, because you can change the domain. And if you don't specify the domain, then there's a default domain, underscore app counters underscore. Or you can specify your own domain, so you can create a container of counters. And then here we're using the index property to create instances of counters. So here the instances I've got are user counters, pointer counters, user points count. These are kind of left over from previous projects, or a requisition counter. But there's at least 3 levels of domains plus the index that can be used. So it gives you a lot of flexibility here. And I tend to put a lot of trace statements in here using the Neo trace controls that are part of NPC. So what it does is it tries to get the counter. It does a get element in the domain for that particular index. If it's missing, of course, then it's going to initialize it by creating a new counter, and then it's going to put that counter into storage. So this is the initial creation of the counter in that storage domain at that index. And then if it isn't missing, that means it already exists. So what we want to do is get it and add 1 to it. So we're going to say, get the current number, and we're going to pass in our NeoCounter entity. So we're going to get the value of that. We're going to add 1 to it. And then we're going to set that new number back into the counter, and then we're going to persist that counter. We're going to persist it into the same domain at the same index. And then we're going to return the current number of that counter, which is the new number plus 1. And similarly, we've got functions for giving back the counter. I'm not sure that those are in here. Yeah, get next and then give back. So it follows a parallel thing. It checks to see if it's missing or not, and because you can't give back something that isn't there. So we just reset it to 0, and then we go through and do that operation by subtracting 1. So that's the smart contract. What do we do next? Oh, here it's just showing take next number, but here I'm explicitly overriding the domain. So rather than taking the default domain, and so I've got another domain just called myCounter5 to support test case 5. But finally we get to the real sort of meat and potatoes, and that's where we're going to use a counter. Counter we haven't used before, so the first time we run this, assuming that their storage has been initialized to 0 in the debugger, when we call take next number on the user counter, which is something I haven't used in this test case, it'll come back 0. So the next index will be 0, and what I'm going to do is create a new user ledger entry by passing in the account script hash for user1 and the user1 passphrase script hash, and those are just constants I've initialized above. I'm going to dump those out, and then I'm going to actually overwrite those with the user2 script hash, account script hash, and user2 passphrase script hash. And the reason why I'm doing that is I'm setting this example up so that it works as a good example for illustrating non-fungible entities. And then finally we're going to put that element. So to write out the ith element of an entity, to create a ledger of users, you need to call take next number to find out what the next index is, i.e. how many items are currently in the collection. You create a new object and you put the new element at that object. and I'm going to do this 10 times. And yes, this is going to be a lot of guess. This is a hypothetical scenario. You wouldn't normally do 10 iterations like this. And then down below here, we're going to call get next number on that counter to find out how many items are actually persisted out on the blockchain. And then we're going to create an array of user ledger entries called users, initialized to the number of users. And then we're going to loop through those user ledger entries that we wrote out to the user ledger in the blockchain. And we're going to loop through, and we're just going to call get element to return those. And because they were created with the counter, they're going to be sequential numbers. So in the case here where we're returning them, we get the number of users by calling the counter, but we never have to call the counter again. We can just create an iteration variable here, an iteration index, and just iterate through those while the iteration is less than or equal to the number of users. And then in this particular case, the result, the object, is actually going to be the array of users. So you can return an array of entities as well, an array of entities which includes non-fungible entities. And the best thing to do is just to run through that. So just click Start. I've already hooked up a NeoDebugger. And I could single step through all this, but maybe just to be brief, because we walked through it in a fair bit of detail, I'm just going to press F5. I'm going to click Debug, and it ran through. And there we can see counter 1. There we can see all the entities being returned, the 10 entities at the end. Here we can see counter 1. We can just scroll down a little bit. We can see counter 1 being created and then put and then gotten back, and we can see that those match. We can see the same thing for counter 2. Down here, we're just showing take next number being run 3 times in a row, so we can see it coming back with 0, 1, 2, and then we can see test case 5 starting with a different counter, and it's going 1, 2, 3 again. And then we get into the case here where we're talking about doing the iterations to create the user ledger. So for every, like I said before, every entity in the user ledger that we want to create, we need to take next number and print it out. So we take next number and it's 0. And then we want to create the user ledger entry, and I output it. Then I change the value of the count, the value of the password, and output it, so we can see that entity is output 3 times. Here's the first one, and then we can see that I've changed the account, and then I've changed the password and output it, and did that 10 times. So we see a lot of those. And then we go down into the bottom here where we're going to read them back. So there's the number of users. Unfortunately, I didn't print out the number of users, so we'll have to update that for next time. But if we go down a little bit farther, 9, 10, there we are. So here's iteration 1, iteration 1, or iteration 0, then iteration 1. We can see that we're reading back those 10 items, and those 10 items then are returned to the main line. So it's pretty interesting, pretty cool way of managing storage. Excellent way to ensure that your keys don't collide. The ability to think again at a higher level, to think in business terms. If you're ever wondering what sits behind these implementations, you just right click and say go to definition, And there's the definition of put element that was used in this particular example. Trying to remember how did that get next number thing work. So you just go in here and it's just doing a get element on the domain for that counter, kind of cool. If we look here, we can see that the CSI file from the model class was automatically brought in and changed to a .cs file. This NeoCounter I had to do no coding for. It was copy and paste the 3 files into my model class, and it's fully implemented here with the capabilities that we saw. So now if we quickly run through a demonstration of how non-fungible entities work, it's simply a question of, let's use user ledger as an example. And let's say we want to make the user script hash non-immutable. It's just simply a question of declaring it as read-only, and that's all you have to do. You go in here, you rebuild the class so that the NPC compiler has something to run against. You click on debug to create a new instance of the NPC support files. If I go up here and rebuild, cool. User ledger entry does not contain a definition of set user script hash. So that's what we want, right? It's read-only, but it actually goes a little bit deeper than that. Let's go in and look at the level 2 support. Level 1 support. So here we can see that set user script hash is commented out. We know that if we look at the class itself, the properties are private, so the only way to access them is actually through those methods that we're looking at. We can see on the set method that we can only set those properties using set if the state is not equal to null. So if this has been set, any values have been set, the state is automatically managed through the life cycle. So the only way to set that property is through the constructor. But the implementation actually goes a little bit deeper than that, quite a bit deeper. For example, if we go and look at put element, we can see that put element has some extra code in it. We normally go out and get the entity state object, but now we're setting a variable called is missing. And so in fact, if the entity state is missing, that means this is a brand new object. If it's a brand new object, then we will write out that immutable property. But as soon as we write it out, it's no longer missing. So this will never execute or update Neo storage again for this particular field. The second field, the phrase, the passphrase, its getters and setters are there, and it's enabled all the time in put. But NPC will now guarantee that if in the model class you declare something to be read-only, the only time you can set it is through the constructor, and once it's been set, it's not modifiable in memory. And when you go to put it into storage, it will only set that immutable property once at the very beginning when it finds the entity to be missing. So this took about 4 hours sitting in the Munich airport on a hard bench, but it was really interesting to see how easy it was to build it into the compiler. So let's go back and look quickly at some last slides here to finish things off. So what I've demonstrated is the idea of creating relatively complex or the beginnings of being able to create relatively complex ledgers. by simply defining an entity and using the existing NeoCounter, the reusable counter. And just to highlight that to create a new entity in the ledger, a new user in the user ledger, it takes 3 calls. One is to call take next number on the user counter or whatever you choose to name that counter. You create the new entity, and then you put it at the index that corresponds to the new number. And you do that over and over. But typically, you're just going to make these 3 calls per invocation of your smart contract. You're not going to do like I'm doing here and execute 10 at a time. And similarly, if you wanted to read and return all the users in a ledger, you can call get next number versus take next number to find out where the counter's at. That tells you how many users you have. You can initialize the users array based on the number of users, and then you just call get element 10 times. And then return that as your value. So just a few words around modeling, every little thing and highlighting the word every little thing. So think of modeling every little thing as little things, almost like neurons on the blockchain. And I owe my good colleague Mark Annabali, creative mind, for coming up with this idea that they really are like small neurons with a small number of properties, and they're networked and connected together. I'm also formalizing this concept of a ledger, which is a specific authoritative collection of entities, stored on the blockchain. And so with NPC, you can have within a single smart contract multiple ledgers. And you can be working with multiple ledgers within a single invocation as long as you stay within the 10 gas. Examples of ledgers. Topic ledger I'm going to talk about a little bit on the next slide. It's a multi-language keyword ledger. I'm working to build a skills ledger on top of the topic ledger. User ledger we saw here. Perhaps there's a token ledger, which is really more of an accounts ledger, like I showed in a previous webcast. And then, organizations ledgers, schools ledgers, XYZ ledgers. And then I'm formalizing the concept of an index, because as you look at the different use cases, as we'll see for the topic ledger, you need alternative indices into a specific ledger. And those indices don't necessarily need to be on-chain because they are derived data. So the ledger is the authoritative collection, but if you need to look at it a different way, that's derived data. You can either implement it on-chain or off-chain. Today, NPC doesn't have support for entities off-chain, but the compiler is easily modifiable to support creating off-chain, an off-chain API that uses the same entity model, but instead of calling storage get and storage put, it might write them into a SQL Server database or a NoSQL database or a JSON file. So that's something that's on the roadmap, to be able to have a symmetric programming model. One, to have a symmetric programming model on-chain and off-chain, and then the concept here is the concept of an index into your ledger. The bit of learning is in a ledger, the keys, the modeling or the design of the keys is as important and as complex as modeling the data itself. So the general pattern is, there's a parent domain, a domain, and an index, and you're mapping that onto entity fields. If you're designing a SQL Server table, you tend to put your primary keys, etc., as part of your entity, but you don't do that with NPC entities on the Neo blockchain because you're trying to conserve the number of puts and number of gets you do. So there's an interesting factoring that takes place here and takes a fair bit of thought. So modeling ELTs as neurons is not easy. Common patterns need to be discovered and documented, and perhaps we can provide some better automation going forward. So if we look at another use case, not one I've described today, but the topic ledger, it's about creating a glossary or a list of terms, nouns, that are translated into multiple languages. So the requirements are, for example, to iterate over all topics in a given language domain, iterate over translations for a given topic, and I guess implicit in that is being able to ask for a given word, find out a specific translation in that case. So the topic ledger, the on-chain topic ledger, the parent domain would be topics, the domain would be English words, and book would be the second word. And in the French domain, the second word, the corresponding second word would be livre, and the corresponding Turkish word for book would be kitap. So that's the authoritative data, but driven by that authoritative data, you could create the reverse index. Again, that could be optionally off-chain. So it would have its own parent domain. The domain would be the word book, and it would map to English. And so you could use that you could make a call from your client application into the smart contract, passing in these three parameters. You're mostly interested in the two, because once you have the two, then you can ask for any language variation of that topic. The topic ledger is going to roll up and be used as part of the skills ledger, and the skills ledger is going to roll up to people, and there's just a whole large interesting model evolving there. So resources, again, all of these links can be found in one way or another on the Neo Blockchain C# Developers Center of Excellence. There's also a brand new workshop for programming smart contracts with .NET, C# and Visual Studio. So this is just plain old straight up C# smart contract development. They don't use NPC. There's an NPC channel on YouTube now. There's technically 9 videos once this one's published. There's one of those is called the Neo Smart Economy, Smart Processes, and Smart Data. There's 3 slides at the beginning of this talk where I talked about NEP-5R and smart processes and agents and that sort of stuff. It was taken from that deck. They were an updated version of what's in this presentation. And then in terms of that, setting up Visual Studio to do that rapid cycle, edit, compile, debug, and execution profiling, execution cost profiling, those are covered in these 2 videos here. And one of the early sort of shorter previews of the NPC platform can be found in this video, and the long kind of detailed deep dive kind of a code review in PowerPoint can be found in this last presentation, and it's a very long 100 minutes. So I leave you with the same challenge that I usually leave you with, and that's to think deeply about, in this case, Neo Smart Agents, aka Neo Neurons. And by that I mean, follow the theme, tokenize every little thing. And in the theme of smart processes and smart agents, think about tokenizing every little business activity. And if you're going to tokenize every little business activity, it comes full circle. You have to think about tokenizing every little thing that's in your business process. And you can read a little bit about that in my blog. The last thing is an interesting pre-announcement. Nate from the Neo community, from the Neo Python community, has started to help convert NPC to work with Python. He's a member of the Neo Blockchain Toronto meetup group and came to me one evening and said, "This looks great. I'd like to do it for Python." So the first step in porting NPC to run or to port the NPC code generator is actually to create a handcrafted translation, handcrafted code generation, and so he's done that for levels 1, 2, and 3 of a C# example. And so I'll be taking this and cutting it into templates, and we'll be retargeting NPC to also produce Python entities. So that's pretty cool. So we're finally to the end. If you want to reach out to me, you can email me at neotoronto@outlook.com. I'm also in the Neo Discord groups on a regular basis, usually in the C# channel. I probably have to hang out in the Python channel now. If you're ever in Toronto, second Wednesday of the month, you can come to the Neo Blockchain Toronto meetup, and the Twitter handle is NeoToronto. Thank you, and hope you found this valuable.